So hopefully you took a chance to try the guided practice on your own, but we're going to go through it just to make sure we're all on the right track.
Okay.
So there are two things you needed to remember when we were going into our guided practice. First of all was our formula. And so what was our formula for our heat of reaction?
Oh, I don't remember. What was it? It's heat of products?
So our H for our products, and that's all of our products together.
Okay.
Minus
the heat of the reactants.
And we got to add all those together too, and we're going to go through and make sure we did that right. The other thing you need to make sure you remembered is if you look up at your chart with all of your numbers, you'll find out you were missing some stuff. But why are we missing things? Which ones do we not ever have to look up because we should just know?
What?
So if it's something on the periodic table, if it's just a pure element by itself,
element by itself, then
it's always going to be zero. Yeah.
Okay.
So remember that.
All right.
Elements are zero, and we'll look at a couple of those.
Okay.
You have those things in your notes, but we're just going to put it here for reference.
Okay. Good.
All right.
Good.
So on this first one, we're going to calculate the heat of formation for the following reaction. We want to figure out if this reaction is endothermic or exothermic. And so endothermic meant it was doing what with its energy?
Endothermic means it's absorbing energy,
so it's absorbing energy, or whether it's giving off our energy. That's our exothermic.
Right.
All right. So we said we needed products minus reactants. So which side's the product side?
Product side is stuff that's being made, so it's on the right of the arrow.
So these are our products.
These
are our reactants. Keep those straight. So on our product side, what's our first product?
We've got 4 of our NOs.
Right, so we've got 4 of our NOs, and if we look up NO up on our table, what is the value for NO?
Where is it? Oh, there it is. It is 90.2.
90.2. Okay. Plus, what's our other product?
H2O.
H2O.
6 of them.
You got to be careful on this one. This is H2O with a G after it.
Oh, it's a gas.
We've got 2 options on our water. We've got water as a gas and water as a liquid.
Okay.
Because it's a gas, we use the one with the G. Just matching.
Okay.
So our number for that is going to be what?
Well, let's see. Let's pull this down here. All right. H2O gas is negative 241.8.
Negative 241.8. All right, and then that's minus all of our reactants. So what's our first reactant?
Our first reactant is NH3.
NH3. So we've got how many of that?
We've got 4 of them.
So 4 NH3s, and if we look up NH3, that's ammonia in our table.
And it's got a negative 46.1.
Negative 46.1. Plus, what's our other reactant?
What is it? O2.
O2. And what do you say is about elements?
It's an element by itself, so it's 0.
It's 0. So we've got 0.
Right.
All right, so now we just plug everything in our calculator.
Okay.
Don't even have to do anything fancy. So we're going to have 4. Oops. Turn it on. Let's turn it. Okay, so 4 times. Yep. And that's why we don't have the lamp on.
There we go. 4 times 90.2 plus 6
times negative 241. And make sure you're using the negative, not the minus.
Okay.
0.8 minus, use parentheses just to be safe, we had 4 NH3s, and that was negative 46.1. Plus, we could just leave this out, but just so we keep track of everything, plus our 0. All right, enter. So that gives the heat of formation, or heat of reaction, of negative 905.6. So that is going to be our answer. And then our units are going to be whatever it said in our table. In this case, it's going to be kilojoules.
Kilojoules.
See, kilojoules on our table. And it typically will be. So those 905.6 kilojoules. Now we have to decide, is this reaction endothermic or exothermic? So are we giving off energy or are we taking in energy?
Okay. How do we tell that?
So think about your bank account.
Right.
If you take in money,
I've got a positive amount.
and if you give out money,
it's negative.
so are we taking in or giving out?
Giving out.
So because we have negative, which means our reaction is going to be exothermic.
Okay.
Here we go. All right, let's look at our next problem. We want to figure out the heat of formation for NH3 given this balanced equation. This one looks a little bit different because here, our heat of reaction,
energy as a product.
it's included.
Huh.
So we can still use it using our same formula.
Okay.
But we need to remember, if it's a product, are we giving it off or taking it in?
Or giving it off.
Giving it off. And what did we just say needed to be our sign on H if we were giving off energy?
Negative?
Negative. So we're going to have negative 92.2 kilojoules is going to equal our products minus our reactants, just like we just did.
Okay.
So if we look at our reaction, what's our only other product?
2 NH3s.
2 NH3. So we're going to have 2, but in this case, we're looking for NH3. We're assuming that we don't know it.
Okay.
So it equals 2 NH3s minus our reactants. What do we notice about both of our reactants?
They're both elements by themselves.
They're both elements by themselves.
So that means they're both 0.
0. So all we end up with is negative 92.2 equals 2 NH3s. And we're trying to find 1 NH3.
Okay.
So we're going to do a little bit of algebra. We'll go ahead and cross out our minus 0 because that's not going to affect.
Right.
So if we're trying to get NH3 by itself, what do we need to do?
Well, if I had a 2 in front of my x in algebra, I'd divide both sides by 2.
So that's what we're going to do here.
Okay.
So divide by 2.
Divide that
Divide
by
2.
2.
So we're going to have negative 92.2.
Oh, you got 2 negatives in there.
Oops. That'll freak out. Negative 92.2 divided by 2. That gives us
Negative 46.1.
And so that's our delta H for NH3. And we can actually check that in our table, and we just used it a minute ago.
Okay.
If you look up at our table, that's what we got.
Oh.
So we got the right answer.
Okay.
All right. You want to pause for a second?
All right.
So now for our last problem. And this is going to go back more toward our basic formula. We want to calculate the heat of formation for the following reaction.
All right.
And so we know that our delta H is going to equal to what?
Our delta H was our, what do we say, the heat of our products minus the heat of our reactants.
And we got to make sure we add all of them up. So what's our only product in this case?
CO2. We've got CO2. 2 of them.
So we've got 2 times whatever CO2 is in the table. So we're going to look down at carbon dioxide.
Okay.
And that's going to be...
Oh, I can't read. What does that say?
Negative 393.5. And remember, if you guys can't read this, you've got it in your packet. So negative 393.5 minus our reactants. And so our reactants in this case are...
we've got CO2.
So 2 CO2s. So, nope, actually that's
COs, sorry.
Be careful with that. That's a really common issue, actually.
Okay.
So we've got 2 COs, and so carbon monoxide is going to be right next to that. And that's negative 110.5. All right. And then we're got to add all of our reactants. So we've got another reactant. What's our other reactant though?
It's oxygen by itself.
Which means it's
0.
0. All right. So now we just have to plug this in our handy-dandy calculator.
Okay.
And so we've got 2 times negative 393.5 minus 2 times negative 110.5. And so that gives us a heat of reaction of
negative 566.
Negative 566, so our delta H is negative 566. Remember, these are going to be kilojoules. So it doesn't ask us this, but if we know we've got a negative heat of reaction, is it endothermic or exothermic?
It's exothermic.
Because we're giving away that energy. Yep. All right.
Okay.
So now you've got practice problems to try and see how you're doing. Remember to ask your teacher if you've got any questions.